Last example, we are finding zeros of an equation. Anytime I'm asked to find zeros of an equation, the first thing that I try to do is factor. Well, this one has a leading coefficient, so I'm going to try the AC method. 2 times 3 is 6, and our middle coefficient is -1. So I would need to find two numbers that multiply to 6 and add to -1. Well, multiplying to +6, I would get 2 times 3, but that adds to 5. -2 times -3, but that adds to -5. If I had -3 plus 2, that would give me a -1, but it would multiply to a -6. This one doesn't factor. So when we have a quadratic function that doesn't factor and we need to find the zeros, we use the quadratic formula. So I will write the quadratic formula down for you again for those that don't have it memorized or don't know the song. I'm not recording that on video. So -b plus or minus the square root of b squared minus 4ac all over 2a. And as a reminder, looking at our quadratic formula up here, a is the coefficient of x squared, b is the coefficient of x, and c is your constant. So when we substitute these values into the quadratic formula, we get the opposite of b, so +1, plus or minus square root of b squared. Even when b is negative, I drop the negative sign when I square it, because once you square it, it becomes positive, and the last thing you need is that negative messing you up. Times a times c all over 2 times a. Simplifying under the radical, I get 1 squared is 1. 4 times 2 is 8 times 3 is 24, all over 4. And of course, I get a negative under the radical. What else would happen when we're talking about imaginary numbers? So we're going to simplify that square root of -3 to -23 to I times the square root of 23. 23 doesn't have any perfect square factors, so this is as simplified as our zeros are going to get. And here are your 2 U-Try questions.